Okay, good. Good morning, everybody. Who enjoyed Replay last night? Great, amazing. And everybody's here still. That's great. Thank you for coming. My name is Michael. I'm a global solutions architect here in AWS, based out of Germany. So I'm happy to be here today with you. I want to talk to you about building end-to-end solutions in IoT today. And happy to have you here. Okay, so let's get started. Actually, I want to discuss basically one large question with you today, which is around building sustainable IoT solutions. It seems to be more complex and more costly than people might expect in the first place. So just setting expectations, this is not a deeply technical talk. We will not go very deep into the AWS services. But the goal is rather to give you an holistic picture of what needs to be considered and things to avoid, basically, some pitfalls to build sustainable and successful IoT solutions. So let's look on the agenda, what I'm going to talk about today with you. First of all, some observations that we see from building IoT solutions with our customers, some pitfalls that you might also see in your environments. Then we talk about working backwards from the actual business opportunity and the actual value, since we see a lot of flaws in that area. And, of course, about security. Security is job zero and needs to be considered specifically in that area. Last but not least, about the features and functions you need to consider, and, of course, some lifetime management and operational concerns. And throughout all this, I'd like to highlight with you how AWS services can help you get started and overcome the most critical complexities in very short time. Good. So let's look into some observations around IoT solution building. There's a lot of numbers out there in the industry. I mean, I'm pretty sure across the different talks over this week you came across several numbers. This now is from Safe at Last, and they say we have like 75 billion IoT devices in the world, and we're adding like 130 new devices to a connected internet every second. Sure, that's a big number. There's basically no value in that number. The value comes with the amount of businesses behind that. This is why so many companies, and also AWS, invest heavily in IoT, right? Whether you're a device manufacturer, a software integrator, an end-to-end solution provider, an infrastructure provider, there's a lot of space to explore to build IoT technology, but also solutions. Good, but let's have a look into that more specifically. While there's a lot of business opportunity, we see a lot of room for improvement when it comes to the implementation. There was an interesting survey that Cisco conducted in 2017. I mean, the numbers are 2 years old now, but I think they're still quite relevant. And they say that basically from the survey, they received information that 60% of the IoT initiatives stall at the proof of concept phase. That means only 40% get out of a proof of concept phase. And even of those little number that actually get into some productive state, 35% of those were suggested as, a positive outcome from the IT folks, but only 15% of the business folks actually said the same. So there seems to be even a different perception between the people who implement the solutions and those who run the businesses. And when you put that all together, it's like 3/4 of all IoT projects fail, right? Wasted money, which is not good for the business, as you can imagine. So the big question is, why is that the case? And when you relate it to regular software development projects, this is a pretty significant difference, because in general IoT, non-IoT general projects, we have like a 1/3 of failure rate. So why is it so difficult? Of course, IoT is new technology. I mean, not so new these days. 2-3 years back, that was different. There's a human factor to it, as in all new innovation concepts. I think it's clear what is behind that. But what we see often is kind of a weak business model. We see this trending, everybody has to do IoT kind of buzzword going on. when you're not in IoT, you do something wrong, so we have to do IoT. But thinking about the value that you actually want to achieve comes not as the first point, and that stalls a lot of projects, basically. So we will look into that specifically in a moment. Also obvious, I guess, IoT comes with a lot of new technological challenges, including connectivity issues you have to deal with. You have to deal with big data, you have to deal with analytics and even machine learning. And that's not easy things to learn. With AWS Stack, you can get a quicker access to these kind of technologies, as you will see. But still, you have to have people who understand that. Specifically in industrial environments, who's from an industrial domain here? A few folks? That's good. OK. So specifically industrial domains, we see a lot of different vendors when it comes to sensors, data providing devices. There's a lot of differences in protocols, in data models, and a massive lack of standards. There are some activities going on to standardize about a few things, like how to model things or how to interact on certain protocols like MQTT. But still, the diversity is very large, and that adds a lot of complexity and cost. Yeah, and all over, when such projects get started, it seems that there is a lack of understanding of the complexities that sit in there. And so we want to cover that today, so to reduce that problem a bit. When we looked into a lot of different projects, even those which I came across over the last 10 years or so, I found like 4 big anti-patterns where people trapped into, and I would like to share them with you. Maybe you see one or the other as a familiar case. The first I call the data graveyard. So something like that. Yeah? We are not sure yet which actual problem we want to solve with the data, but let's collect it all. Right? Collect all the data in one central place, build some infrastructure in order to collect it from all the devices, and we will see what we will do with it. So what happens here is that you generate cost in the first place. You collect data, and collection of data is not free. You have data transfer cost, you have storage cost, and at some point in time, people will ask a question, what is the value on the business side that we get out of that? When you don't have a good answer to that, and the cost comes with no business return, then you know what happens. And then the data lake becomes a data graveyard. Who came across that? Somebody? At least one? Sorry for you. OK, the second one, the security nightmare. Yeah, we solve this security thing later. Security is expensive, we do that later. No. Security needs in the first moment of thinking. This is not only because it's on vogue. We will have a specific talk about that in a moment. But you have to put it into your first level of POCs in the first place. Getting an idea what the risk scenarios are, what the different scenarios might be you want to cover at the first place to avoid the minimal, or let's say to avoid the obvious problems in the first place. Lifecycle ignorance. I have seen people, specifically from the business side, figuring that after a POC, people were able to ingest data, right? You do a POC, you spend like 4 weeks. Hey, our data is now flowing in, that's great. On the business side, yes, we're done. Let's go to market. Not quite. When you have data flowing into your data lake, this is like the beginning, not the end of things. So this is like when you have your first MVP put into production, this is where all the cost starts, actually. Getting into a first situation where you have data inflow and basically connected your devices is a starting point. And 80% of the cost is still to come. And the last one, the industrial barricade. I have seen companies that were very successful in the consumer domain, excuse me, and coming from the internet, and then had the idea to expand into industrial, but failed. And one of the reasons is there's no DHCP or DNS suddenly in the factory, which might be unusual to somebody who's just familiar with internet technologies. There's a lot of security concern around industrial, and you need to specifically accommodate for very high-level requirements and very sophisticated security concerns when you want to go industrial with your IoT solution, specifically when you want to transfer data out of industrial facilities into a central cloud-based solution. So that's pretty significant. You need to wrap your hand around that quite early. So let's have a look how to build things with AWS. And as usual in AWS, we do not start with technology. Even we are pretty technology-oriented, as you know. We always think first from the customer side, what problems can we actually solve? And in AWS IoT, we see basically solutions in all different domains. So what we're telling here is basically applicable to mostly all the domains. Maybe predictive maintenance in industrial environments, maybe wellness and healthcare solutions, or any other thing. Connected buildings, we have people in the room who build solutions for connected buildings, and all this is pretty significant. But which kind of business problems you actually can solve with AWS technology? I want to give you some examples so to get an idea what is possible. The first example is build actually new business models. The classic one is something as a service. You may have heard about it when you enter your aircraft, maybe today or tomorrow to get back home. The engines of that aircraft may not belong to the actual owner of the aircraft. They are rented. And they're not rented is the wrong word. They're actually sold by hour in the air, right? So the engine provider, like Rolls-Royce, they do not sell engines anymore. They sell operating hours. And the same you can do with a windmill. You don't sell a windmill. You place a windmill into an environment and you sell kilowatts generated per hour. And this is only possible when you have a good technological base in order to operate the device on behalf of your customer, right? Which means you need good data inflow in order to understand what is the behavior of that system and to be able to maintain an entire fleet in the world of these kind of devices. Another business model is build products better. So it's all about feedback and what is the next decision in your product roadmap. Make the example, you are a TV manufacturer and you want to understand which apps on the smart TV are used by your customers. What you do is you gain telemetry data within the TV and send that back to your central instance so that a product manager can look into the entire fleet of sold devices which were connected by the customers, what is used, what is not. And that gives pretty good insight about what might be the next requirement on the roadmap. As this is only a small example, I think you can explore it, the options there. So telemetry data gives you a lot of insight how your products are actually used in the field. By collecting those on continuous basis, you can make smart database decisions on how the roadmap should look like. Another example, relationship with your customers. Think about the famous printer example. You have a printer at home, it runs with ink runs low, it's empty, you want to print, no cartridges, bad, not nice. A connected printer is different because it will know that the printer cartridge is running low, and suddenly you have a package at home, maybe it's an Amazon package, including the Inter cartridges. You wonder why are they here, and you figure then that your ink cartridge is low by 10%. So proactively helping customers, not forcing them to be reactive when things break. Just one example, but there's many others. Operate products better. What is the optimal scenario to run a motor? Motors break, we know that, industrial example, when they overheat, when the current is too high, and other factors come into play. And you might to think about the optimal environment where the motor can run based on telemetry data in that specific scenario. So the question is how to maximize operational efficiency and to minimize downtimes. What comes into effect here also is product support to optimize that. For instance, when you have that motor example, you know that something will break, or when you have an acoustic measurement of an gearbox, then you hear inside, and from the noise, you understand whether there will be some breaks. You can proactively plan service and maintenance, and that means scheduling service personnel out there, informing the customer that he should have a planned downtime for that device over the next 48 hours, and not being reactive in a way that it breaks, production goes down, and you have a massive loss of money because of unplanned downtime. And in combination with operate products better, this is a massive use case in terms of the business value. Still, a lot of businesses run mainly on the service contracts. Products are sold quite cheap. Service is quite expensive. And here you can get even more efficiencies and better support. Last but not least, think about the factories, how to build the products better, right? Here, this is a very industrial scenario. You have a lot of industrial field devices, and you want to figure out where the quality flaws in your production come from. You want to optimize resource consumption. You want to minimize energy consumption, for instance. And here, with telemetry and high-density information, you can figure out what are the relations between the quality output of your factory and the actual resources consumed and the inputs. There's a lot of opportunity here. What is in common to all these cases, they all need the collection of data and the interpretation of data. So just collecting data alone has no value. It's absolutely useless. You need to have actionable insights. And actionable, what that means, we will discuss in a moment. One example of my customer, which is Siemens. By the way, Siemens folks in the room, raise hands. Yeah, ooh, that's a lot. Great to have you here. This is Junelight. This is a product that Siemens has released recently, and it's a battery that sits in the basement of your home. It collects the energy from your photoelectric system on the roof. And this device is basically totally IoT enabled, which means it runs several IoT software pieces provided by AWS and uses the AWS infrastructure to collect data and provide insights to the customer. We will see some more examples around that in a few moments. Okay, so how to build a business case? Typically, business cases, I mean, most of you may know that, how they are built is pretty straightforward. But when it comes to IoT, it is a data-driven question, right? So typically, there's two ways to get into business opportunities when it comes to IoT. First is you know something. You know there's a lack of efficiency. You know their customer experience is not good. Customers tell you maybe that things are not right. And then you have a business opportunity right at hand. Known problems. On the other side, it might be that you have a bunch of data, and by just looking into the data, you gain opportunities. This is a classical data science issue. In Siemens, we just recently had a nice case where people looked into the data of a steel coil, the steel quality parameters, so to say, and the end result, which was a big transformer of the size half of that room, and its noise emission. So there's a correlation in data between the parameters of steel, which is used to manufacture a large-scale transformer. And based on data scientists' work, they were able to figure out an opportunity here that then is being implemented by IoT technology. So you basically have to ask two major questions. So before you do any technological things, you have to ask yourself two questions and find the answers. Which actions you want to trigger, and what data do you need for that? Right? So what action means, do you want to help a product manager to make a better decision? Do you want to inform a customer about a certain situation with the devices? Do you want to make recommendations to your customers? What is it that you want to achieve? And how it's been triggered, and which data do you need from that? And when you have that information, then the classical business case creation comes into play. So what is your value proposition? What is the addressable market? And to come to an idea what the revenue might be, you need to understand the cost. And as usual, it's about building the solution, 20% of the cost, operating the solution, 80% of the cost. And this is the idea when you do POCs, the things you have done until the POC ends or bring the product into the market is like 20% of the cost, which defines your price situation. So what the relation might be to your customer is around the operations. So how many people do you need to operate the solution, maintain it, and enhance it, along with the infrastructure costs? That's important. So in that Siemens example, the actions that they wanted to trigger is basically to actively inform the customer and provide recommendations about the power usage in the house. So when should you run your washing machine so that you have a minimal consumption of external power and maximize the use of solar power, as an example. And the data that I needed for that was basically all the data from the device, power in, power out, currents, and so on, but also additional information from the outside. For instance, a historical view of the consumption, but also maybe something like the external power market prices in order to make better recommendations. And because of just that knowledge, they found an idea to work backwards into the implementation and make things work. Okay, now we thought about business cases and values, which is good. Technology. In AWS, you get a set of technologies. As we learned, we have now 175 services. I want to show you just a few of those. And here in the IoT space, we have a set of services in 3 different areas. The first set is device software. So here we have FreeRTOS, which is an operating system that runs on your microcontroller. The Siemens solution I showed you uses that. We have our device SDKs, which basically help you to create clients that can connect to our IoT core system. And we have Greengrass. Greengrass is a piece of software that you can install into your device, an edge device, for instance, or your end product. And you can run Lambda functions in there. You can run local machine learning inference. You can run any kind of container as well. And it provides you like a secure infrastructure in order to connect to the cloud and have safe and secure communication channels. On the cloud side, the essential part is IoT Core. IoT Core is a message broker in its essential basis that allows devices to securely connect and scale massively to the millions of devices. Device management helps you to deal with large amounts of devices in terms of, for instance, firmware management, but also configuration management, organizing these devices into groups and fleets. And Device Defender is a tool that helps you identify malicious devices and block devices that are out of normal operation. Then we have data services like IoT Analytics in the middle here, which acts as a time series data store basically, and helps you build materialized views in order to analyze the data. Things Graph is an application that tries to make it very easy for you to build end-to-end solutions just by graphical editors and using standardized libraries to connect devices and applications. Sidewise is a tool that helps you to collect data from industrial environments. OPC-UA is the current protocol supported. Build hierarchical data models for your assets, and then also visualize that in dashboards. That's pretty new releases as we learned this re-envan. And IoT Events is also a product that helps you to understand the raw data better and generate new events out of given rule sets for the data that's flowing in. So these are the things around the IoT scope, but we will look into more details, of course, how they can be applied in the larger context. As usual, in Amazon, everybody's pretty security concerned, as you know. And when you think about your IoT solution, you should be too. And there's a set of targets that we should have in mind. The first always is customer data protection. When you build an IoT solution, you most probably transfer data out of an environment that is customer-owned, may it be a factory, but also the customer's home place, his smartwatch, the TV, maybe some larger fleets of trucks. Who knows? But the data that's flowing out of there is the customer's property in most cases, and you need to be careful about that. I think that's obvious. The second is the customer's environment, maybe not as obvious. When you bring software into an environment in order to collect data, that software is your liability. And with that liability comes that you have to react to threats that might harm the customer's environment. And the third is you have to protect your IoT backend. Okay, your IoT backend is a web application, it's exposed to the internet, so you have to protect it. What is new in IoT is that you have to deal with malicious devices. Denial of service attacks from devices that were captured is a common case and needs to be considered. And the fourth, of course, legal compliances. There's a lot of data regulation and legal rules that you have to comply to, specifically data locality. So when you collect data from a certain factory, to keep that example, or household, and you put it back into your central AWS instance, maybe in the US, then it's a data export legally. So for instance, when you collect data in Germany, it needs to stay in Germany. This is why most of my customers run their IoT applications in Frankfurt, because then data stays within the EU. In the Siemens example, no? The protection goals. How can that be an issue with the device like that, you might wonder. The customer data needs to be protected because let's assume somebody steals that information. We have 50 million households connected to that device, and somebody actually enters that database and gets the information out. What you get is basically a profile of energy consumption, which tells you how the family that lives there actually, functions to a certain extent. And it can be misused, of course, because when energy consumption is low, you can assume nobody's at home, and that might be, an invitation for people trying to steal stuff. It's like posting in social media that you're on vacation and open that to the world. It's like the same risk level. Customer environment. Think about that solution. You have a battery in your basement that runs software on it to control it. When somebody with bad intentions gets into that piece of software, can modify it, can it basically modify it in a way that it's overheating and maybe causing fire in your house. And when you have 50 million devices out there, hopefully, customer business case is good, but then this is a nice attack target. Yeah? Getting 50 million houses into fire in just one software download is a nice scenario for some people, so you have to take care and make sure that these kind of scenarios do not happen. Okay. Some measures. When it's about protecting customer data, it's all about encryption. I think that's pretty obvious. What is new in IoT is that you also have to take care about the device itself. When you're coming from a cloud environment, protection in the cloud is in AWS an easy thing because most of the services have encryption options. Transport encryption is also pretty much solved, TLS. Encryption on the device you need to consider. That means a device can be stolen. Think about an oil refinery, very large space, or an airport. There's a lot of devices out there which hold local data and buffer it. You need a screwdriver to get that device, and then you can do funny things. So make sure that the data is encrypted there. And the other part is around mutual authentication and identification, making sure that whatever data you collect on the device in the field sends it to the right backend, not to somebody who has generated a rogue backend, right? That's pretty important. The services that we have here, IoT Greengrass, FreeRTOS, and IoT Core, provide you with a lot of features around that. So everything is secured by certificates in AWS solutions. So every device has the certificate on it and authenticated actively against the broker. And that is deeply embedded into these services. The same with encryption. We use HTTPS, so TLS-based encryption for all data transport. And that gives you a quick start on these kind of issues. Customer's environment. The most important thing is, and that needs to be in the first version of your IoT solution, no matter what, you have to be the capability to update every single device down there in the field, anytime. That is super important because your software will basically not be the best software of the world when it's in the first version. And you use third-party libraries a lot, which might also have security flaws. And in the moment you realize that there's a security flaw in there, you need to have the ability to patch everything at once. It's the same like you're running your EC2 fleets in Amazon, in AWS. With Patch Manager, you can basically manage all that. You also think about your devices in the fields, which might be in the thousands or 10,000 or millions, maybe, how to patch them. That's pretty important. And when you do that, you have to be sure about the integrity of the software. Think about a scenario that you have created a nice software distribution platform where you can update all the field devices at once. That's great, 1 million devices out there. And somebody sneaks in there and manipulates your firmware in a negative sense. With the next rollout, you're happy announcing new features, whoop, roll out to 1 million devices, and the bad software is in there because your attacker was actively manipulating your repository. With that, you have created a dream for every hacker because you're rolling out the bad code for him. Think about that. So how to ensure the integrity of device software and downloads. The bad thing is you have to consider that there will be cases where people can manipulate your devices and still cannot cause harm to your customer's environment. So specifically when you talk industrial or manufacturing, that is pretty costly. Bring down a manufacturing device can be very expensive. When you think about healthcare, it can actually cause human life to danger, and so this is pretty serious. Along with that, we have active device version management because all your devices in the field will have a drift in versions over time. That will be the case. Not all the devices will have all the latest patches always, and you need to be able to cope with that. So the services that we have here help you to a certain extent. Specifically managing device management here, IoT device management helps you to manage your fleets. When there's a lot of devices out there, you can organize by certain tags, build groups, manage rollouts specifically. For instance, you can manage rollouts to certain countries or based on certain versions of your firmware. And the services in IoT Core, Greengrass, and FreeRTOS all contain options to have over-the-air updates. You can issue jobs into the device, get firmware management down, and the software itself, like Greengrass, has over-the-air update functionality. So by using these services, you get a lot of the raw functionality that you would need in order to operate the things more securely. Backend protection is pretty obvious, as it's a web application, I mentioned that. But what is specific to IoT is the piece about device onboarding. Think about the scenario. You have manufactured a device, which is a data collection device. Maybe it's a piece of software that sits on your product. It's manufactured, and then at some point in time, the customer gets it into its hands, and then you need to onboard it to your backend system, right? It needs to register somehow. Now it's active, now it's there. And this onboarding process needs to be secure in a way that it cannot onboard to a rogue backend system. And on the other hand, only legitimate devices can onboard. And you want to block and identify those devices which are not legitimate, so which are malicious. These days, it's pretty easy to clone devices, virtualization. So when somebody steals one of your devices in the field, identifies how that works, makes 1 million clones, and wants to all onboard them to your backend, you should have good measures in place to prevent that. Same with distributed denial of service through devices. It's a pretty common case. We talk about botnets through IoT devices here. Your backend needs to be able to resist these kind of attacks. Yeah? This is pretty much the same as an attack through the internet, but in this case, it's coming from your devices. Application protection, we have this largely in AWS. There's a lot of different services like Web Application Firewall and GuardDuty and many, many else that help you protect the cloud environment. For the device side, of course, the only thing to mention here is Device Defender. Device Defender is a service that helps you to understand what is the normal behavior of an IoT device and define rules around that. And it gives you information about devices that are not normal, right, that behave outside this defined rule set. It also uses machine learning to accommodate that. And with that, you can automatically block these kind of devices and figure out what's going on before they cause harm. So this is super important and generates a lot of security, basically with no effort from your side, just by utilizing the service. Data privacy and compliance. Here we talked about this data sovereignty issue, and with the AWS regions at hand, you have the options to deploy locally, which also then enables you to build solutions that keep data in the same country as they were generated, or at least in the same region. And you can also export software locally. What does that mean? Maybe not everybody's aware of that. I came to that also by chance. When you have a firmware update for your device, and you send that firmware update from a central cloud instance into the device, when you cross a boundary of a country, it's a software export. So that means that's intellectual property that's leaving, for instance, the US and going into wherever your device is. Legally, software export, intellectual property over borders. Think about that. It might kill your business in some of the regions when the government puts rules on top of you. So with local installations, you can at least distribute software then from central places and remote regions. And of course, the general AWS security posture. I think there's a lot of sessions in reInvent that help you around understanding the other security concepts that we have, but it helps you to leverage all that and give you a certified level of security from the first day on. Okay, now we talked a lot about the business case and security. Actually, we did not think about a single piece of how do we get from a piece of data into some insights. We will do that now. I would like to explore with you the features and functions you need to consider. Some of that might be obvious, but let's look into that. Maybe we find something that makes a new for you. So let's look at the entire chain. First, you have to have the data at hand. When in your business plan, you identified which data you need in order to trigger actions with your customer, you have to somehow expose the data. That might be as easy as fetching data from a smartphone, like the GPS information, but it might also as complex as adding new sensors to an environment that does not have the information yet. So this motor example that I had, if you want to know the temperature of a motor brake and there's no sensor, you have to attach it. And that means physical screws, it means a lot of wiring, you need to have field devices that actually can convert this information and all these kind of things. Then you need to connect to the sources of the information, transfer it into the cloud. In the cloud, you ingest the data and pre-process it, you store it, you analyze it, maybe use machine learning even, and then you want to present the insights. Or trigger actions automatically, and hopefully you do also some field feedback collection. That means measuring if the action that you actually triggered caused some positive effect. Let's go into the details. So I mentioned that, sensor, system, and networks. The interesting thing is when you start from the business value part and you think about which data points do you actually need, you will figure in most cases that only sensor data is not enough. You would like to augment that with other information from CRM systems, SAP systems maybe, some databases that sit in your backyard, whatever. Even internet information like the weather is one of those which is integrated most. And you need to think about how to connect to this information, basically. Also in industrial scenarios, pretty significant. Not all the information sits on systems that can talk TCP/IP. That's pretty common. Older installations specifically have bus systems that are not able to talk TCP/IP, and you have to bring the information into a device that can talk TCP/IP. That, in many cases, can cause a lot of complexity. You have to deal with all the different protocols and formats that are out there, and you need to have a connection to the internet, which is pretty obvious. Like I said, in an industrial environment, not always very trivial. Think about local collection, local buffering, local error handling. Oh, sorry. That was quick. Oh. Yeah, now. Yeah, I mentioned the services already. To just explain Sitewise for a moment. Sitewise has a local data collector as part of the offering, which you can install into Greengrass. When you have Greengrass on one of your devices, you can have a site-wise connector in there, and that allows you to easily connect to OPC UA sources and more sources over time, and so have an easy attachment to these sensor information. Okay, transfer, ingest, and processing. First of all, you have to think about offline and online handling. When you attach a train to your IoT solution, a train is a moving thing, and connectivity is not always given. I think you can imagine that. A lot of people struggle with the idea what it means to be offline for a while, and how long is that sustainable. You need to locally collect data, you need to store it. At some point in time, the data doesn't make sense anymore when it's too old, and all these kind of scenarios come into play. Your connectivity should be firewall friendly. This is why the AWS services implemented MQTT on top of HTTPS, because HTTPS is more firewall friendly. When you have enterprise customers and you want to get data out of these enterprises, you have to have a serious talk with the network administrators and the security officers of your enterprise customer when it comes to which protocols might leave the enterprise. And here HTTP over TLS is a common option that is accepted the most. Transfer cost. A lot of IoT projects start with the idea we collect everything in the highest possible density, with the highest possible cycles of data transfer. Every second, 500,000 sensor points. Good. That's great, because then you have a lot of good information in the cloud. You can use the cloud resources and scalability to make sense of the data. But when you transfer that over 4G, 5G, maybe in the future, that might be costly, right? And not in all places you have the bandwidth that you would need. So very early in these scenarios, you come to the point that you have to compress data. You need to reduce the sending cycle times. You need even to think about minimizing the amount of data being sent just to save transfer costs, because that can kill a business case. Think about scaling. Doing things with 1 or 2 devices is fun, but basically not a business case. So hundreds and millions of devices, you need to think about scaling. IoT Core here plays its strength because it scales basically infinitely without any configuration need from your side. Also important, the entire part about the data. You need to know which data model you want to have the data in. And that means you need to transform the data, which is coming from your sensors, from your devices, into that design and target data model. You need to think about data cleansing, data enrichment, data transformations, and integrate all the information with the third-party data that you need in order to bring the customer value. So here, a lot of data integration and data processing is required to build the quality of data you need for the later analysis and machine learning. Of course, you have a lot of different AWS services that can help you, right? The IoT services help you mainly on the ingestion part to get the data from the device and have a direct activity that works on the data. And then you can use things like AWS Lambda, but also Glue, Kinesis to further process the data, ingest it, and do all the transformation that are required. To mention specifically Sitewise, Sitewise has capabilities to do data modeling and also implement rules for data transformation. So in here, you have now the first capabilities to define a target model and define the required transformations along with it. So with Sitewise, things get more integrated and easy, while you have, with the other services, all the options to code your own transformations and do whatever is required. Yeah, storage. Storage seems to be pretty straightforward, but when we talk about sustainable IoT solutions, you have to think about optimal cost storage and performance ratios. People start often with the idea, we put everything in DynamoDB. Everything in DynamoDB is a cool thing, because DynamoDB provides a lot of low latency features. You can access the data pretty quickly with low latency, and that's great. Problem is when you have millions and trillions of data points and you have high IOPS requirements on DynamoDB, this becomes expensive. We know that. So then people start thinking differently, and you come to the point of tiered storages, hot, warm, cold. Data that is required in super high performance, you put into stores like DynamoDB, which have low latency features, but maybe more costly. And the colder stuff maybe sits in S3, and you use Athena on top of it to query the data. Much better. Also, S3 have that idea of tiered storage. You can automatically tier down into cheaper storages, trading the price with the actual access performance. But you also need data catalogs and inventory management to understand what's going on. You want to maybe have monitoring and alerts over the data flow, while to understand during operations if the quality of the data is still good and everything works fine. So monitoring and operations also hits the data quality at that point. Of course, you want to analyze with a variety of tools. To generate the insights, that's pretty obvious. You use SQL and other technologies in order to do the analytics. And then you leverage, of course, SageMaker and other machine learning capabilities to gain insights. While this is only a one-line statement here, I think that it brings a lot of complexity for itself. Getting the data clean, analyzable, or be able to do machine learning is an art of itself. With SageMaker, this becomes much more easier, but you need to consider it. As you see, I mean, we have a lot of different services that come into play here. I think we touched one of those. What is specifically interesting here, when we think about machine learning, training models that work on your IoT data to build good customer insights, predictions, classifications, and these kind of things is absolutely necessary these days. To be in a position to be on top of the technology, you need to have machine learning capabilities in your organization. When we correlate that with the idea that transfer cost is expensive, then the question is how to do the inference in the most cost-effective way. And then things come into play like local inference that sits on your devices. With SageMaker, you have the option to analyze data and train data models around algorithms. You can also do inference in SageMaker in the cloud, but that would require that you stream all your IoT data into the cloud to actually infer on it. With the combination of Greengrass, you can do the inference locally. That means you send the data to the cloud once to train the data models, maybe in chunks, which is cheap, highly compressed, and these kind of things, not real time. Then you train your data model, and then bring the trained data model down to Greengrass. And the AWS services here have a tight integration so that you can have a good transition from SageMaker into Greengrass to deploy your models. And that allows you to infer on the high-density data locally on your edge device, in your gateway, in your end product device directly, and provide customer value down there while not required to send high-density data over the network, which is quite expensive. So with this scenario, which is kind of a pattern these days, you can build very high-performance machine learning-enabled capabilities. Good. OK, let's assume we have now insights. These insights sit in IT systems still. Yeah? When a machine learning algorithm tells you on an API level things happened, or please inform your customer, you need ways to do that. I think the most straightforward is human presentation. There's a maturity model in, let's say, IoT applications and solutions where the lowest level is simple monitoring. First, transparency. What happens in my factory? What happens with the fleet of my trucks? What happens with all the customers that uses my TV at home? And present simply the information in a nice dashboard so that humans can look at it and derive action from it. But this is just the beginning. When you are at that stage, the next might be to integrate with downstream systems to automate things, right? An example here might be a ticketing system for a service engineer. Based on machine learning, you found out that a certain device will break and that you need a replacement part, and you want to order that replacement part over an SAP system, and you want to create a service order in the ticketing system of your service organization, and that requires API calls on these devices, systems, and for that you need technical integration. The same with processes and workflows. A service order might be a complex process that is started, and you want to trigger workflow systems, right? So we're thinking about coming from a monitoring kind of approach, which is always the first stage, into more autonomous and automated actions. And this ends as a vision into a situation where we have a full closed cycle, closed loop automation based on IoT data that allows to automatically trigger activity and then measure again if the activity was a positive thing by telemetry data again. So IoT there is self-enforcing and can be thought into fully autonomous and fully automated configuration loops. In industrial environments, this is kind of a discussed item because it includes also some, safety discussions around, is that validated? How safe is it to fully automate configuration changes in the field? Yes, that's a way to go. But in the end game is around that. As you can imagine, we have a lot of different services that help you here. Hello? Specifically mentioning QuickSight here. QuickSight is a business intelligence tool that helps you build dashboards based on data that sits in AWS data stores. And in Sidewise, we also have a first version of the monitoring dashboarding tool that allows you to visualize IoT data. And on the right-hand side, you find a lot of services that help you integrating with downstream systems. You can have Lambda functions triggered that execute code calling other systems' APIs, or you use integration tools like SQS or SNS to have a message-driven integration. Okay, so this is the end-to-end feature set, from data exposure in the field to integration to trigger downstream actions. As mentioned before, this is not the end of the story. You need to think about the life cycle of the entire thing, and you need to operate your IT solution as well as you need to operate any software solution. And oftentimes, this is the basis for building a sustainable concept. IoT solutions cost something. They're considered pretty expensive because you need to implement a lot of infrastructure from data collection over analytics, machine learning, inference, downstream integration to create customer value. And oftentimes, when you are just monitoring use cases, this value is small. It starts small. It becomes more interesting when you get into predictions, into higher level insights generations that come more into recommendations, for instance. Then the value gets increasingly more. But until then, you have to minimize the operational cost to get into that level. And that means, you have to think about how to operate it at minimal cost. And as mentioned before, the services that we have include a lot of features that help you operating, like Device Manager that can deal with large-scale device fleet. So, while we have a lot of knowledge around how to manage software as such, software applications, also cloud-native software applications, for many of us who are coming more from the internet side, managing the device lifecycle might be something new. So what you have to do basically is that you have to bring the software that you need to collect the data and maybe do local inference. Let's talk about Greengrass in this scenario, or your own software, and integrate it into some hardware that sits in the field. It might be your own device that you, like the television example or the battery example from Siemens. Then you do the integration at home, which is easy, and deliver it as one package. But in other cases, you might bring software into a brownfield that already has some compute somewhere, and you install it there. But then you get the liability of that piece of software. Or you need to figure out how your customer takes liability of that. Then you deliver the software and integrate it into the device, and then you commission it. That means the device becomes operational, you have to onboard it, right? We mentioned that before, and then you operate the device. The fun part here is, or the interesting part is that you have to deal with these initial scenarios, and they're not trivial in some cases, depending on your solution and your products, and need specific consideration. Device operation itself mainly is around the software update management, the software inventory management, the entire configuration changes, having the devices in sync to what you want them to be, because they are offline sometimes, you need to take care of that. Regional rollouts, local rollouts, software inventory management over country borders, these kind of questions. And last but not least, certificates. As I mentioned before, in AWS IoT, devices are identified via certificates in the device. And you need to have an idea how you get these certificates into the device, in the software that runs in your field from the first moment on, but also continuously while they're being updated. Yeah. And there's also side scenarios, just to mention it in the back of your head. Devices get decommissioned. Hardware fails, need to be replaced. Sometimes things are being sold to other customers. Computer tomographs, for instance, in the hospitals are sold to other hospitals quite often, as I learned. And then this thing suddenly pops up on another customer. And you have to deal with these scenarios. It might not be your MVP first kind of scenario, but it will come over time. And most of it all, don't think about 2 devices, think about millions. And then operations becomes only feasible if you fully automate it. If you don't think automation, you're out of the game from the first moment on. As simple as that. Last but not least, just to mention it, every IoT solution is a big data solution. When you start with your IoT use case, you might connect a few devices, they send a bit of data. That's easy. Over time, you attach more devices. When your business is successful, you attach a lot of devices, millions. And then the data which you have to handle with is big data. We're talking about terabytes, megabytes, and petabytes, maybe, depending on your use case. And you need to have a strategy how you deal with it. Optimize between cost, performance, but also purge data if required, and manage the entire life cycle. Tools like S3 come very handy in here because they have a lot of features around that. Okay, let's conclude on that. So you remember the gentleman who said in the beginning IoT solutions in general are pretty complex and cost expensive. Hopefully when you use the AWS services that I mentioned here, you get a quick start. You can run your POC quite quickly, and also at POC stage, you have a decent amount of security and operational quality already in your system so that you can focus on your business insights, right? Because there all the value sits. Cool. Please consider the related breakouts. I think there's a lot of more to deep dive into. We covered just the basics today. And of course, there's a lot of learning opportunity in our web pages where you can have a first look into the IoT services. With that, I want to thank you for your time. Have safe travels back home. If you have questions, I will be around for another hour here. See you then. Bye-bye.